Hello everyone and welcome back. In this video I'm going to be working through question number 5 on page 32 of the textbook. So it says, the following objects have been drawn on isometric dot paper where the distance between dots is 2 centimeters. So I'm going to start with a legend here. Okay, very important because it's telling me that each unit is worth more than 1. So the distance between dots, it's telling us, is 2 centimeters. So every single square that can be made out of the dots on this paper is 2 centimeters by 2 centimeters. Length times width, 2 times 2. Okay, so every single one of the little squares in this design has an area of 4 centimeters squared. Determine the surface area of each object. Okay, so that is my legend. Taking a look at A. Okay, I've got a rectangular prism with just the corner cut out. Okay, so remember, when you have just the corner cut out, you don't actually lose any surface area from your basic rectangular prism. So we can simply break this down into our 3 matching views, front and back, left and right, top and bottom. Okay, so I am going to call this larger face right here, this one right here, whoops, that one, the front. But like I've said before, it doesn't really matter if you call this here the front or this here the front, as long as you're not repeating the same sides when you're doing your calculations. So I'm going to call this one here the front. And then of course the back would be the opposite to that, and it would be identical. So whatever I calculate for the front, I will double to account for the back. So keeping in mind that every single distance between 2 dots is 2 centimeters. So that means I'm just going to count by 2's for my length and my width. So my width, I've got 2, 4, 6, 8 by 2, 4, 6, 8, 10, 12. Left and right, so since I called that the front, that makes this my left side. And the right side would be right back here. Can't see it, but it's identical. So whatever I get for this left side, I'll just double to also account for the right side. So again, let's just count by 2's. So I've got the width here, 2, 4, 6, by the length, 2, 4, 6, 8. And finally, my top and my bottom. Again, matching faces, so I'll double it. I've got a width here of 2, 4, 6 by a length of 2, 4, 6, 8, 10, 12. Okay, so let's do some multiplication here now. Starting with my front slash back. Each of those is worth 96. And then my left and right, each of those is worth 48. And top and bottom, 6 times 12, 72. Okay, so now I just got to double each of these to account for the front and the back. Whoops, what happened here? To account for the left and the right. And finally, double the last one, 2 times 72, to account for the top and the bottom. Okay, final step is just to add up all 3 sets of matching sides. 192 plus 96 plus 144 equals 432. My original units, centimeters, and its area, so centimeters squared. Final answer. That takes care of number 5. Sorry, number 5A. On to 5B. Okay, so for B, I've got both a tunnel shape and I am following a different kind of legend, which is still this one where every distance between 2 dots is worth not 1 centimeter, but 2. Okay, so that just means that I have to count by 2s. Okay, the other thing is, because I am looking at a tunnel shape here, I don't just have to do these 3 sets. I have to do calculations for the outside and the inside, the tunnel. So one part of my formula I'm going to designate outside, the other part I'm going to designate inside. From there, outside, nothing different here. Break it down, front, back, left, right, top, bottom. And inside the tunnel, there is no front, back because that face is missing. That's cut away. That's literally why we have the tunnel. But we do have a left and a right matching sides, and we do have a top and a bottom to the inside of that tunnel. Okay, and then of course the final step will be to add both the outside and the inside together. So focusing on the outside, front will be matching to the back, so whatever I get I will double it. Counting by 2s, I've got a length of 2, 4, 6 by a width of 2, 4, 6. Oh, so this is actually a square face. But then remember, I'm missing this little window shape here. So I'm going to subtract that. So that's 2 by 2. Okay, notice this time I ended up calling this part the front side. I probably should have called this the front just to be consistent, but like I've said before, it really doesn't matter as long as you're not double calculating the same sides. Okay, so that means that I got to stick with that scheme, and I'm going to call this my side. So this would be my right side. So I'll double it to get the left side that I can't see. So we've got 2, 4, 6 by 2, 4, 6. Again, another square face. And finally, my top, 2, 4, 6 by 2, 4, 6. Would you look at that? It's actually a perfect cube with a tunnel through it. Okay, and of course I'll double it to also account for the bottom that I cannot see, but that I know is identical. So, here we go. 6 times 6 is 36. 2 times 2 is 4. 36 minus 4 is 32. 6 times 6 is 36. And 6 times 6, again, 36. So now let's double it all up to account for the back, right, and bottom. So 32 doubled becomes 64. 36 doubled becomes 72. And once again, 36 doubled becomes 72. So that takes care of my outside. Now onto the inside, the inner part of the tunnel. So the left side that I can see here, I've got a width of 2, and I will double it to account for the right that I can't see. And the length, I really can't see, but I know that it runs all the way through because it says right here, the hole extends all the way through, and it runs parallel to this line down here. So that means the measure of this length running all the way through will be the same as this parallel line. So that's 2, 4, 6. Okay, and then top and bottom, I can kind of see a bit of the bottom of the tunnel here. So I've got a width of 2. Of course, I'll double it to also account for the top. So 2 by, and again, the length is running all the way through this, and it's running parallel to this same line again. So that's 2, 4, 6. 2 times 6 is 12. 2 times 6 is 12. 12 times 2, 24. And again, 12 doubled, 24. Oops, how did I end up with those down there? Doesn't matter. So, outside plus my inside. Add it all up. So, on the outside, I had an area of 64 plus 72 plus 72, plus on the inside, I had 24 plus 24, total 256, and original units, centimeters, area, so squared, centimeters squared, 256 centimeters squared. Okay, so that's it for this video, guys. Thanks so much for watching. See you in the next one.